Good morning, children. How are you? Yes, I am also fine. So we are very near to finish this chapter, triangle chapter. Very smoothly, we have learned everything. We have learned the properties of similar triangles. We have learned about the midpoint theorem. We have learned about the angle bisector theorems. We have learned about the rules that can be used to make two triangles similar here. So these all things we have learned in our online classes. See how useful this is. So now we are going to discuss one more important topic of this chapter, and that is called Pythagoras theorem. Okay, so these all things we have learned. See, these all things we have learned. Okay, meet this ratios of area also we have learned now. Now what is that Pythagoras theorem? Okay, what does it mean? It means that in Pythagoras theorem, definition shows the relation among the three sides of a right triangle. And what is that? The square of hypotenuse is equal to the sum of the squares of the two sides. And since right triangles follow this rule, and they are called Pythagoras theorem triangle, only the right triangles where the angle is 90 degree. Okay, I'll show you that also. See this. This is one right angle triangle. Okay, this is one right angle triangle here. This part is hypotenuse. This is called base, and this is called perpendicular. So this h square is equal to p square plus b square. So this is what Pythagoras theorem states about. Okay, so one more important thing here I would like to share with you, that midpoint of the hypotenuse is equidistant from the vertices. This is a very important thing here. This is, if this is the midpoint here, then this vertex, these distances will be equal, and they are called circumcenter. See that also. The midpoint of the hypotenuse of a right triangle is circumcenter of the triangle. And why it is circumcenter triangle? Because the radii of the circles are congruent, and the circumcenter is visible from the vertex of the triangle. So in right triangle, the perpendicular bisectors intersect on the hypotenuse of the triangle. Understood now why that is called the circumcenter and why that is equidistant? So everything has a reason here also, and we are going to use this property in our solution here. So let us see that one video that I have made for you. So here is that video. First of all, let me explain this question here. Question is saying that angle B is equal to 90 degree in triangle ABC, and AB is equal to root 3 BC. Prove that angle C is equal to 60 degree. So let me draw that figure of this question here, and here is that question. Okay, so this is the question here. It has been given that AB is equal to root 3 BC, and this is 90 degree also. Angle B is equal to 90 degree also. So that means triangle ABC is a right angle triangle. So we can use here Pythagoras. We have to prove that angle C is equal to 60 degree. Okay, now we can find that AC is required by Pythagoras theorem only. See, we are using this Pythagoras theorem here also, that by Pythagoras we can say hypotenuse square is equal to base square plus perpendicular square. That means AC square is equal to AB square plus BC square. Okay, and what is AB? That is root 3 BC. Okay, and BC square is itself there. That means AB square, AC square is equal to 3 BC square plus BC square, means AC square is equal to 4 BC square. Clear? By help of this Pythagoras, we have found the relationship between AC and BC of the sides of a right triangle ABC. Now what? Now we will deduce what is the actual value of AC, and that AC is equal to 2 BC. That also is correct. Since AC square is equal to 4 BC square, that means AC is equal to twice of BC. Okay, now we can take one midpoint on the D. Yes, we can take the midpoint of AC. We don't have problem. We can measure and we can take. And this AD, this point D will be joined with the vertex B, with the vertex B there. Okay, so DB is joined, and in such a way that D becomes the midpoint of the, and here that in circumcenter concept will come. Okay, now see, I think you have understood this. This angle I have to prove 60 degree. This, that means what? That means if I can prove these all sides are equal, automatically this becomes 60 degree. Understand? For that reason I will use that circumcenter concept of a right triangle there. Okay, so that vertex will be equal here. So see how I will use that. So now, so if I have to solve a questions, I have to keep all the details, okay, in my hand, then only I can solve. Okay, so now AD is equal to DC, because I have said only D is the midpoint, that is equal to AC by 2. That means twice of DC is equal to AC. Twice of DC is equal to AC. It is also correct here. And twice of DC is equal to twice of BC, because AC is equal to 2BC. So DC is equal to BC here. Okay, we have found DC is equal to BC, and now that circumcenter concept is going to be used here. Okay, D is the midpoint of hypotenuse, that means it is the circumcenters. Okay, here that means now what? That means here that DB is equal to DC. Okay, now we can use that the from that midpoint of hypotenuse, that is AC, from the midpoint of AC, we know just now I have explained also, all these three sides are equal. I explained that BD is equal to DC, just now I have said. Okay, I have said, no, BD is equal to DC, and I have proved that DC is equal to BC. That means all these three sides are equal. All these three sides are equal only. So if these are equal, obviously it is an equilateral triangle. Obviously angles are 60 degree only. So see, BC is equal to BD is equal to DC. So we can say that triangle BDC is an equilateral triangle. Am I right? Yes, exactly. BDC is an equilateral triangle. So all sides are equal. So angle C is equal to 60 degree. And this is what we had to prove, and we have proved also. Okay. So what we used here? We used the Pythagoras theorem. We use the circumcenter concept. So these things we have to learn, and through this video and through the online classes we can learn also nicely. So come on time, be regular, don't miss any class, and we can learn everything there. Okay class, thank you very much. In the next class we learn something new. Till then, all of you take care. Thank you class, thank you very much.